discrete versus continuous functions. So a discrete function is defined only for a set of input numbers that can be listed and nothing in between. The inputs have distinct and separate unconnected values, which means we may know the input should be 0, 2, and 4, and we may know the corresponding outputs, but we can't connect what's happening between 0 and 2 if we don't have that distinct information. Whereas a continuous function allows the inputs to be any value in a finite or infinite interval, including fractions, decimals, and irrational values. So if we have a continuous function, we can plug in every possible value between 0 and 2 if our interval is 0 to 2. So we could plug in 0, 1, 2. We could plug in things like 0.1, 0.111, 0.11111, so on and so forth. So every single possible value is included in a continuous function. So let's continue and look at our examples of the types of functions we've been looking at before and try to determine if our formula first is going to be continuous or discrete on the given interval. So notice here that our formula y equals x squared minus 2x minus 3 doesn't have a defined interval. That means we are assuming that we are looking at the entire possible interval from negative infinity to infinity. If you are not given a restricted interval, you can assume all values unless otherwise stated. So here, this function is going to be continuous because we can plug in any value for x, which is our independent variable. We could plug in 1, 2, 3, 4, 5, 6, 7, on and on and on. We could plug in positive numbers, negative numbers, 0, decimals, with no problems whatsoever. There's nothing about this function that is telling us otherwise. So this type of function, which is called a polynomial, is continuous. Consider now the graph below. So this graph, again, has a distinct y value for every possible value of x that we see on this graph. Now this graph looks like it's only defined from negative 6.5 to positive 6.5 because that is what shows up on the graph and there are no arrows at the ends of the functions. So here, there is an imposed interval that we can visually see based on the picture, but this function is still continuous on that interval because for every x value, there is a corresponding y value, no matter how small that x value is. So for 1.111111, we could find a y value. We'd have to be really careful, but we could do it. So this function on this graph is continuous. Now let's take a look at our table. So remember that our tables are really helpful because they usually contain data, okay? And when we have data, we have points. So here we have the point 0, 3. So that means that when x is 0, we know that the dependent value is going to be 3. At 2, it's 7. At 4, it's 19. At 6, it's 39. However, we don't know what's happening at 1, or if a value exists. We don't know what's happening at 0.5. We don't know what's happening between 0 and 2, 2 and 4, 4 and 6. Therefore, since we only have defined information at specific points, this function is discrete. Finally, we can look at our word problem. So here, the cost of ice cream, C in dollars, at the local shop in Mathtown, Ohio, is a function of the number of toppings T ordered to be put on the ice cream. So C equals f of T. We need to figure out if our function is defined for all values of T or just specific values of T. So here, think about what T represents. T is the number of toppings. So if you choose M&Ms and Oreos, then the number of toppings is 2. It doesn't make sense to have 1.5 toppings or 1.111 toppings because as soon as you choose a second topping, T becomes 2, which means that the values that T can take on have to be integers. Things like 0, 1, 2, 3, 4, 5. Since it doesn't make sense to have values in between, again, this function is discrete. Now, most of the things that we look at in this class are continuous. However, when we have word problems and tables, there are cases where we will look at discrete functions, especially in tables which are inherently discrete. So while we will continue to go forward in this course knowing that we'll mostly look at continuous functions, we have to remember that there are special properties and ways that we have to consider when we have discrete functions. And some of those things will come up later today.